So most of our questions are going to be dealing with price elasticity of demand, but it is important to note that in the same way that, there's a responsiveness in consumers to changes in price that are just built into the definitions and the curves that we have for demand and supply. Similarly, there are certain responsivenesses that are built into the supply curve. Now, when we talk about the supply curve, though, the supply curve we can't have as a straight line for reasons that we're going to see in a second. And we have something that is slightly convex. Convex? Yeah, concave is this way, convex. So something that is slightly convex, so it has a little bit of a bend to it. And if we are looking at rental units, and we're talking about how many, different apartment rental units or whatever are going to be, in Chadron, right? Let's say if there's 100 right now, and the average price of a, one bedroom is going to be $650, compared to if, there's a new apartment building opening up, and they're going to add, an extra 30 rental units. And so at 130, then the price is going to be $700. So let's go ahead and calculate our price elasticity of demand. So our price elasticity of supply. So our elasticity of quantity supply is equal to my percentage change in my quantity supplied divided by my percentage change in my price, using that midpoint formula. I'm going to go ahead and I'm going to label my points. So actually, let's stick to our convention that we had before. So 130, 700, and this one is going to be 100, 650. And so I'm going to do my quantities first. So my quantities, I'm going to have Q1 and Q2. Then I'll do my prices, P1, P2. All right. So my percentage change and my quantity supplied, see, I'm so used to doing demand, it just comes out, is going to be 130 minus 100 divided by 130 plus 100 divided by 2, which is 115. So this ends up being 30 divided by 115. My percentage change in my price is going to equal my P2 minus P1. So this is going to be 700 minus 650 divided by the midpoint between 700 and 650, which is 675. This is going to give me 50 over 675. And I'll get us some numbers for this in a second. So 30 divided by 115 is times 100 is equal to 26%. So the percentage change in quantity was 26%. And the percentage change in the price is going to be 50 divided by 675 times 100. So this is going to be 7.4%. And then we just put them together, right? We put this down here. We put this up here. 26% divided by 7.4%. This is obviously going to be greater than 1, but how much greater than 1 is it going to be? It's 3.5. Or sorry, it's greater than 1. So this is price elastic. or yes, has a supply price elasticity that is greater than 1, so it's elastic in terms of its supply. I don't know the best way to say that. Words are failing me today, class. I'm sorry. Does that make sense how to calculate it, though? The new minus old over midpoint? Okay, cool. All right. We've got a couple of edge cases that we talk about, right? If something is completely up and down, then this has 0 elasticity. If something is completely flat, then we have infinite elasticity.
Something like the crown jewels or something that's one-off?
Well, infinite elasticity is actually something that is it's the opposite, something that's really, really common. So it's something that essentially, the way I think about it, it's if you price it above this, the demand goes to 0. So there's just so much competition and so many substitutes.
Sand here.
Yeah, exactly. Right. Right. But even then, I mean, people pay a lot for sand, and people pay for clean air. You know, I mean, like, you know what I mean. So it's hard, right? It's hard to find something that really fits in either one of these categories, because, you know, even insulin, right, which used to be the perfect example of this, now they have synthetic insulin, right? Yeah, they have competition. Yeah, yeah. So these are just, again, these are theoreticals more than they are practicalities, right? These are the edge cases. And then when we're talking about constant elasticity, it's going to look different for supply and for demand. So for demand, it's going to be I don't even know if that does it justice. It's going to be a curve. It looks kind of like that. So this has a unit elasticity, and by unit we mean it has an elasticity equal to 1 everywhere. So if I did the calculation from here to here, it would be 1. If I did the calculation from here to here, it would be 1. So this is the case where, again, every change in the price is matched by a change in the quantity demanded, right? So you try to run a sale and your total revenue goes nowhere. You lower the price, but the increase in the demand is exactly enough to make up for the lower price that you're receiving on all of the units that you are selling, right? Correspondingly, if you increase the price, you're going to lose the amount of customers exactly equivalent to what you increase the price of. So your total revenue, in either case, when you're in a unitary demand curve, there's no way to increase total revenue. You're at max total revenue. Supply looks weird. It's not terribly important. It's kind of more of a footnote than anything else. I think the book brings it up just for completeness, since we talk about the perfect elasticity for demand. You know, I'm sure people are like, well, what's perfect elasticity for supply look like? That is a flat line out of the origin of 0, 0. So those are the requirements there. And the slope here, m is equal to the slope here. So again, there's some examples of this, so you can kind of prove this to yourself from the text. I don't think we have the time or energy. Oh, we actually don't have the time at all because we have to do a Kahoot. All right, so we're going to pick up with elasticity and pricing first thing in class on Monday.